Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook, 7th edition. And we have question 75. The system consisting of the bar OA, two identical pulleys, and a section of thin tape is subjected to two 180 Newton tensile forces as shown, and we need to determine the equivalent force couple system at point O. So basically we have these two forces, and all we need to do in here is to find the force couple system, meaning we need the force and a couple at the end of the question. So the force part is pretty easy. We're going to go with the sum of all forces that we can see in the figure. We can call our x and y in here. So looking at this, we'll see that the two forces are same magnitude in the opposite direction and they are non-collinear, which means they're gonna make a couple in here. So that's the definition of couple. So two forces that are equal 180, they are in the opposite direction and they are non-collinear, meaning one of them is above the other one or they're not in the same line. So first of all, the sum of all forces will be 0 because same forces equal opposite direction, they're going to cancel each other out, so 0 for that. And what we have basically is a couple of these two forces, and for couple we have a different method for finding the moment. And when we have a couple, we just need to use this formula, which is force times d, and we have to figure out what is d, and the d is the distance that we have between these two forces. So all we need to do in here is to figure that out, and the rest of that should be easy. So how we're going to find that force, and the way we're going to do this is that we're going to consider this right triangle that I'm showing in red. This angle here would be 45 degrees, and we know the hypotenuse here would be the radius of each of these plus this part. This part is 100 millimeter, so we basically have 100 millimeter plus r. So if you want to calculate that, it's pretty easy. We know that we basically have 100 plus 225, so the hypotenuse is 150. So this is 150, and our d, if you want to find our d, I'm gonna show it in blue. Our d would be this distance, which is r, plus what we have in here, plus another r. So if you want to find here, this will be basically 150 sine of 45 degrees. We already have the force. The force is 180, and the d would be basically 150 sine of 45 degrees plus 2r. Each r is 25, so plus 25 plus 25. If we calculate this, it's going to give us 21.7 Newton meter, and as we can see, the couple is in this direction. So counterclockwise, we're going to call counterclockwise moment positive as always. So counterclockwise, that's going to be our moment. That's one way to do it. The other way would be to going straight with the moment about point O. And if we do that, we need this distance here. And for finding that, we basically have this distance here minus what we have in here, which is r, and the other one would be basically 50 sine of 45 degrees. So that's one moment from this force, which will be as we can see, it's clockwise negative. And the other one would be the moment of 180, which is going to be in this direction, so counterclockwise positive. And if we want to find distance from O to the line of action, which is here, what we're going to have, we can take this part, can take the bigger right triangle, and we know the hypotenuse is 150, so this will be 150 sine of 45 degrees plus here, which is r, and that's going to be another moment, which is a positive moment from the other force. So you guys maybe try that one out. Let me know if you get the same answer at what we got in here. Both of them work. The first one is way easier because it's coming from the definition of the couple, and we have to remember what is couple, which is a moment produced by two equal forces in the opposite direction that are non-collinear. That wraps it up for today's video. Let me know if you guys have any questions. Please make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students, and give me any feedback that you think is going to improve the videos, and I'll consider that in the next videos. I really appreciate your feedbacks on these videos, and you guys take care. I'll see you in the next video. Have a good one.